Indeed have a hello everyone. Good morning, afternoon, or evening, depending on where you are. Thanks for tuning in. Let's do some destination check. If you're looking to spend your next hour in the most informative way, you are at the right place. We indeed have a very interesting subject at hand to discuss at this webinar. It's discussing 3GPP release 17 and how it is laying the foundation for the next phase of 5G. And it is timely as well. And I'll talk about timeliness in a little while. Let's start with some quick introductions. As we have, we have two speakers. Um, we have two speakers. I am Prakash Sangam. I'm the founder and principal at Tantra Analyst, and also have Safi Khan, who is the regional product marketing director at Telit. He'll join me. So we divide this presentation into two parts. First, I'll introduce and talk about release 17 itself, what it entails. No, it's stable. Sorry. Okay. What it entails, what is included in it, why we should care, why you should care about release 17, and so on. And after that, Safi will talk about some of the strategies to transition from wherever you are, release 15 or 16 into release 17, especially for IoT players in the market. And we'll follow that up with the Q&A session. We'll take your questions, audience questions, so please keep them coming. You can type them in the Q&A section of your portal. So let's get started with some quick introductions. I am Prakash Sangam, as I mentioned. I'm principal and founder of Tantra Analyst. We are a 3-year-old boutique tech industry analysis, research, and advisory firm covering 5G, AI, IoT, and other tech areas. I personally have more than 20 years of experience in the cellular industry, going back to 2G days even. Before starting my own venture, I worked for AT&T, Ericsson, and Qualcomm in that order. So you can say I have a well-rounded experience in the mobile industry as such. I write for Forbes, have my section at RCR Wireless News, and I write for many other publications as well. And I also host a podcast called Tantra's Mantra. You might ask why I'm qualified to talk about release 17. Well, I'm a full 3GPP member, attend all of the plenaries and so on. And that brings us to this timeliness of this webinar. As we speak, 3GPP RAN plenary and TSG plenary is going on. It will run for the next 2 weeks or so. And that plenary will exactly discuss and finalize some of the things that we'll talk about release 17 and 18 in our webinar, right? So that's it can't be more timely than that for this webinar. So let's get started. I think we are at a place where we can call 5G is mainstream, right? Close to 500 operators investing in 5G. Close to 200 have already launched. Who have not launched are either trialing or doing deployments and so on. As you can see from the chart, almost every operator in the world, except for a few in the African region, have some sort of a 5G plan. Either they have launched, trialing, or investing in 5G. So I think we are at a place where we can comfortably call 5G is becoming mainstream. And the traction is not only on the operator side, it's also on the device side as well. So far, close to 1,200 more device models have been announced, and close to 1,000 have been, commercial and shipping. That's extremely fast way of adoption of any technology as such from a device perspective. And also interesting is if you look at the spread of these types of devices between smartphones and every other device, be it industrial routers, modules, and other things, it's almost a 50-50 split. Actually, it's the smartphones are little less than 50%, All the time we hear about 5G smartphones in the market, but they're only half the story. And as we move forward, I expect that percentage of smartphones to even shrink further, mainly because release 16 and 17 and the other future releases are primarily focused on IoT as such. So it is very easy to estimate that smartphones, obviously everything will grow, but the share of IoT versus smartphones will be different than what it is today. So if you look at the roadmap itself, um, obviously 5G NR and 5G was introduced in release 15. So the first focus was to get this new radio interface going, and also commercializing 5G NR radio interface. And when we went to release 16, which was finalized June of last year in 2020, the primary focus was stabilizing uh, enhanced mobile broadband. The primary focus was still enhanced mobile broadband, and also stabilizing some of the specs for that were introduced in release 15 and so on. And when you look at release 17, it is squarely looking at IoT and industry verticals and making sure and all the things that they need are covered in the specifications. And going forward with release 18, the focus is more on future topics like using AI, ML in the networks, and so on. So although these are specific, there are specific focus areas for these various releases, but the 3GPP specification and standard development is a very iterative process. What do I mean by that? Well, you take any new concept, it is introduced in one release, it is improved upon in the second release, in the next release, and perfected in the next release. So when you look at the specifications themselves, you will see that there is a component of almost every feature in every release. So it's not that you will hardly ever see any feature is a single shot is done and completed in one release, unless it is very unpopular and no operator is looking at using it. It will always be a evolution. So you'll see a lot of enhance, further enhance, and so on in the name of the features themselves, right? So double clicking on the release 17 and 18 timelines, a little bit of a detailed view here. This is published by 3GPP itself. Release 17 is what I call COVID release, mainly because most of the development of release 17 has happened during COVID time. Why does that matter? Well, 3GPP thrives on face-to-face meetings. A lot of the things are thrashed out, when people sit together, facing each other, talking about the differences, and coming up with the consensus specifications. Well, that was not possible with the COVID going on, with this global pandemic. So 3GPP itself has to, scramble and start working on an online basis, like everybody in the world, and come up with a good process to make sure they make progress. They did indeed, achieve a lot of progress, and specifications are developed, but it kind of elongated the timeline of release 17 itself. There was, I think, depending on how we look at it, at least 2 or 3 quarters of delay in finalizing release 17. And the latest update is that it will be finalized by mid third quarter of 2022. That's next year, and that is what is called as ASN.1 release, and that is the point from which vendors can start developing commercial products. And that ASN.1 freeze will happen sometime in Q3 of 2022. Obviously, there will be evolution and enhancements after that, but that is where you are putting the foot in on the putting on foot on the ground and saying, we have robust set of specifications ready for companies to start productizing, right? And obviously release 18 work has already started. As I said, it's happening this week as well, looking at what are some of the possible areas for exploration, evaluation, and ultimately development of standards in the release 18 and beyond. And the commercial timeline is like 2024 or beyond for release 18, probably a little longer as well. Release 17. As I said, the primary focus is IoT and industry verticals, and it is designed specifically for that. What is different between this and the previous releases? Earlier, the specifications and standards were primarily were developed for smartphones and mobile broadband communications, and they were later adopted for IoT and verticals. But with mostly from release 16 and almost of release 17 has taken a little bit of a different approach, wherein the requirements and the needs of the IoT are addressed, are the front and center of specification development. So, and making sure that those requirements that the industry has are met in this specification, not just adopting specifications later. So those are the front and center in terms of developments. I have mentioned some of the industry verticals that TGPP is looking at, but it's a small set. I would say any industry that uses connectivity in some sort of shape, some sort of shape, will be touched by 5G and can benefit from 5G, and ultimately the requirements of those industries will be taken into consideration. Right. So this is the complete comprehensive list of features that release 17 is that 3GPP is working on for release 17. And that's quite an exhaustive list, and quite a few features. So there's a lot of work going on in terms of development. Um, Obviously, we'll not have time to go to each one of them and explore all of them. It'll take not only days, probably weeks to complete. Instead, uh, what we are doing is breaking these features into three buckets, if you will, and meaningful buckets, I would add, and then look at some of the important, interesting, and more impactful features that in each of these buckets. And what are those buckets? The first is new concepts. What are the new concepts that Release 17 is bringing to the table? The second bucket is what are some of the release 16 features that are being enhanced in release 17? And the third bucket is what are some of the release 15 features that are being perfected, fine-tuned, and so on. So we'll break those into three buckets and go to each of these buckets in a little bit of a detail, right? And by the way, as I mentioned, please make sure if you keep questions coming, ask them in the Q&A section of the portal. We will get to them once we are done with the presentation. Should have enough time to get to some of the questions. Okay, so what are the new concepts in the release 17? The first one is, it's kind of a hype everywhere in the tech industry right now with metaverse and everything else. It's looking at extended reality, which is combination of AR, VR, and other things. So the task here is evaluating what is needed in 5G links to support these applications. Obviously, you have to look at the latency needed. You have to look at where is the processing is it should be located, whether it has to be everything in the device, which may not be possible many times. Whether the processing can be done at the cloud or can it be in between somewhere in the edge cloud. How the architecture will look like, and so on, to make sure extended reality really possible on a 5G network. That's the focus of the development. First, evaluating and developing standards to support that. That's what's happening. So the whole idea is to optimize the processing power, where you do the processing, and the power consumption of the device stage to make sure you provide best user experience, right? And the second new concept is millimeter wave. Well, you might say millimeter has been there since release 15, even before that with IGTF and so on. What's new? Well, here the new thing is extending it beyond what is done today. It only is supported till 52.6 gigahertz. Now 17 will look at beyond that up to 71 megahertz. Why it is different? Some of the RF characteristics will be different between now and then, when you go to even higher speeds. So looking at that, and obviously you can get much wider bandwidths. It's only up to 800 megahertz now with release 17. With this expanded range, you can go up to 2 gigahertz of bandwidth. And then with that you get even higher speeds. Not that we know, but not that we need them, but nonetheless you'll get them but more importantly, even more capacity than what we have. It's a, you're looking at much longer term than what is really needed right now, right, in these villages. So, bringing in more capacity and also addressing all kinds of spectrum, shared spectrum and unlicensed spectrum in millimeter wave. That's kind of the focus of millimeter wave action in release 17. And another exciting thing is what's called as NTN, non-terrestrial networks. Here, you're looking at using satellite networks, LEO, low Earth orbit, or geosynchronous orbit satellites to provide connectivity on the ground. And it is more of a complementary to terrestrial because it's very extremely hard to provide satellite connectivity for networks on the ground, for the device on the ground. Primarily, this is looking at providing IoT kind of connectivity within our or NB-IoT or LTE-M. And some of the use cases are areas where it is extremely expensive to provide coverage or not possible to provide coverage. Some examples are, rural areas where farmlands, you need a lot of IoT connectivity there with moisture sensor and other things, but it is very expensive to deploy, sometimes impossible to deploy, 5G networks there. Then, you could use satellite networks, to provide expensive coverage and provide IoT services with NTN. And also, if you look at seas, it's lots of shipping happening on the seas, high seas. It's impossible to provide any other way than satellite communication there, and using NTN for those kinds of applications. So it's very complementary, not competitive with terrestrial networks. And the fourth interesting area is multicast and broadcast, 5G MBS. Broadcast has been studied since 3G days, and some deployments here and there as well. But this is the first time broadcast is coming into 5G. That's in release 17. It is looking at both multicast, wherein you are providing broadcast kind of services in only limited areas, and broadcast, where it is network wide as well. And the focus here is, looking at simplifying the deployment, management of mobile broadband systems or broadcast systems when it is compared to 4G, so that you simplify it for the operators and think they will buy it. Some of the use cases being looked at: public safety, not just live TV, but public safety, FOTA and a firmware over there upgrades, and automotives are one of the key industries looking at using broadcast. It's so much now. Cars are almost software defined. A lot of software going to cars. FOTA is emerging as one of the applications for such technology. We'll still have to see. We have been talking about for, as I mentioned, broadcast for a long time, but whether 5G is the time where operators will take it, we'll wait and see. Right. So, quickly looking at the release 70, release one of the most important new concept in release 17 is what is called as RedCap, reduced capability. It's so important that reason I made a specific site for itself. So the concept of a RedCap is pretty straightforward. If you consider now, we are covering the extreme ends of the performance. On the lower side, you have NB-IoT and LTM, where you provide very low data rates but extremely long battery life and high latency. Right, latency is not consideration. So that's on one extreme, and on the other extreme, you have you know enhanced mobile broadband providing hundreds of megabits of speed, and you have URLLC providing extremely low latency and extremely high reliability kind of applications and services. So you have the two extremes covered, but there are many applications and use cases in between wherein you don't need those extreme battery life and extreme reliability and latency of extreme high rates. So how do you do that? That's exactly what RedCap is. It kind of encompasses everything that 5G NR does in these three classical circles that we know of: EMBB, massive IoT, and URLLC, but doing them to a certain extent, not going to the extreme. That's the reason why I put that circle in the center. It has all the components, but not to the extreme, just where is needed. The whole idea is to lower the complexity. And how you do that? by reducing the number of receive chains. So you instead of having two, you have one. Instead of 4 by 4 MIMO, for example, you have only two. So you have less MIMO layers, less receive chains. You reduce the complexity and supporting the smaller bandwidths. Typically in FR1, like in sub 6, the minimum bandwidth 5G NR supports was 100 megahertz. In FR2, it is 400 megahertz, 200 to 400 megahertz. But with 5G, with RedCap, you have a minimum of 20 megahertz, more like LTE. Then you are reducing the modulation. 256 uh, QAM was normal in 5G, but here the max you can go is 64 QAM with RedCap. And you're looking at a half duplex rather than full duplex, which means with half duplex, you're less complex RF because you're not transmitting and receiving at the same time, right? So all of this obviously reduces the BOM, bill of material on a device, and then it lowers the cost so that you can address not these extreme needs, what is the basic needs for typical use cases, and then provide and address that with a reasonable price point. And the initial targets are wearables is one, like watches and other things, where you need a little bit of everything but not the extremes. And there are many IoT use cases and device types that are emerging with RedCap. There's lot of interest across the board from all the players in 3GPP regarding RedCap, right? So one of the key uh, key concepts in release 17. So looking at some of the release 16 features that are being enhanced, I doubt I'll have enough time to go to each one of them. So IAB, I'll focus on a little bit because it's new concept introduced. It's being perfected in release 17. The whole idea of IAB is you have single box, you have wireless on both sides, both backhaul as well as the user side, and it's extremely cost effective to use IAB for millimeter wave densification. I actually have written a series of article on IAB and what it takes, how they are beneficial with some studies on how you need and how you deploy and so on. I highly encourage you to check that out. The article series is on RC Wireless News as well as on my website tantraanalyst.com. The second one is a precise positioning. This is really critical for IoT, especially industrial IoT, automating the factories and so on, where your centimeter level location, precise location in indoors. It's not based on GPS. It's purely based on cellular connectivity. Looking at the RTT, return time delay, angle of arrival, angle of departure, and so on. Right? It's really critical for factory use cases. Sidelink, it's basically taking the C V2X and expanding that to other use cases like public safety, emergency services, and even smartphone based applications and so on. Small data transmission is interesting. Right now, even if you have a sensor that needs to send like few bytes of information, it still has to go through a full call setup. With the small data transmission, you can actually send a small data burst even when you are inactive, so don't have to go through the full call setup cycle. And in release, it was introduced in 16 17 as many enhancements so that you keep the battery life maximized and the power consumption lower. And URLLC on unlicensed. That is interesting, right? URLLC is all about this low latency and ultra low latency, ultra high reliability, and unlicensed is typically it's not reliable and so on because anybody can barge in. That's the beauty of this work item, in wherein how you can fortify the frame structure and such that even you can provide very good reliability on unlicensed spectrum. So that's the one of the interesting things that at least I thought that 3GP is working at. So perfecting the release 15 features. It's quite a long laundry list of things that's happening here. Some of them are MIMO enhancements. MRDC is multi-radio dual connectivity. All of these are commercially available now in commercial networks because most of the networks that are deployed today are release 15, and some enhancements coming in to make them even better. One thing I'll focus on is this coverage extensions. As you all know, most of the 5G networks are deployed in spectrum that is slightly higher than 4G. For example, 3.5 is a very popular band, C-band and others, whereas the 4G is deployed in 2.1 gigahertz or lower. So this feature is looking at how to bridge the coverage gap between 4G and 5G. Some of the things this feature is doing is removing the bottleneck in the signaling, as well as making the signaling robust so that you can get the signaling channels U1 at the cell edge much farther than the cell edge. And if you can close the signaling link, then you can extend the coverage and so on, right? So that's one of the key things it's looking at. Some of the other things, multi-SIM, RAN slicing, self-organizing network, and UE power saying and some others. Of course, it's a very long list. I'm just mentioning some of the key things and interesting as well as impactful ones here. So now looking forward, release 18, obviously the work has started. It's very initial work looking at what should be included. And also a couple of months ago, maybe like 4 months ago, 3GPP came and gave a name to it. So releases beyond release 18 will be called as 5G advanced. Maybe it will be 2 or 3 releases before 6G. So it will start from release 18. As I mentioned, because of iterative process, it will work on release. It will work on enhancing many of the features introduced before, but some of the concepts it is looking at as new are interesting ones. The first one is using AI and ML for wireless links, not on devices, but on both network as well as on devices. The key here is making sure right now the link 5G link itself is static, the frame structure and everything. Here you're looking at using AI ML on both sides to make sure you adapt the network, the radio interface itself, to whatever the application and the use case that the link is being used for. It's a tall order, very challenging, but there are some ways how 3GP is looking at to make it work. We'll see how that goes, but that is one of the exciting things that are happening. We have always talked about, oh, we'll improve that, we'll improve performance, we'll lower the power and so on. Ultimately, those are the end goals to make sure the link best possible. But using AI and ML is a different approach than industry has worked on so far. So it will be interesting to see how that progresses and standardization. The other important thing is looking at full duplex operation. It's not using the same frequency, single frequency, but using sub-band full duplex. This is one way to achieve that ultra low latency that 5G has always promised. And the other end is lowering the energy consumption. With climate change being a top subject, 3GP has done a lot to reduce the power consumption, but now with release 18, it is taking it to the next level, making it one of the goals of the standardization to reduce the power consumption on the network side. Obviously, on the device, it's always been a consideration, but now making sure the consumption of power by the radio base stations, lowering that to shorten the smaller the carbon footprint of networks as such as well, right? So those are the high level things that release 18 is looking at. So to summarize, from release 18 perspective, 5G is almost mainstream now. Release 17 is looking at and is squarely designed for IoT and industry verticals. There are many enhancements for previous features, but also there are many new concepts as well in release 17. And industry is looking forward and has a strong roadmap with release 18 and 5G Advanced, right? Release 18 and beyond. So with that, let me hand it off to Safi to talk about migration strategies. Again, I would like to remind you guys to think about the questions, ask them. We'll try to address as much as we can. Safi, take it away.
Thank you, Prakash. That was a very good summary and analysis of 5G features. I learned a lot too from listening to Prakash's breakdown. So from my perspective, I'm going to switch gears and actually get into what does it take to commercialize these releases for the industry. And Telit is a leader in IoT and M2M communications, and we build 5G products such as modules, which are pre-certified, and they go into use cases that I will cover, which are basically beyond handsets. So obviously, 3GPP and 5G is mainly driven by the smartphone and led by the smartphone commercialization. And then behind that, it's another second wave where the same technology is then made available for IoT devices. And with more and more connectivity propagating down into many of the devices, it is very important to understand the challenges that we face when you have to commercialize releases that are coming out almost every 2 years. So let's get into that discussion. So just to quickly recap the timeline, which is what I will try to focus on. As Prakash mentioned, right, 3GPP is continuously evolving and improving the standard so that the features, the work items, the study items are thoroughly flushed out, vetted, and specs are firmed up for the industry. So we are currently finishing up release 17, and in parallel, the release 18 package has already kicked off, and that will be called 5G Advanced. So this you already heard. What I want to do is
Okay.
take you
I'm
over.
okay, that's fine. No, I don't eat meat, but
Prakash, can you mute? Thanks. So what I will focus on is, the commercialization aspect, as I mentioned earlier. So let's take a look at what happens. So let's say that release 17 gets frozen by the 3GPP, which is the ASM.1 code freeze that was mentioned. So let's say you are here, you freeze the code. So now everybody knows what the spec includes, what features are in, what are mandatory, what are optional, so on and so forth. Now, companies such as Qualcomm have to build the chipset that implements that standard. So this is where the frozen spec is really helpful, because the chip development cycle is not very small by any means. It's a very complicated process. And so the semiconductor companies will develop the entire chipset. So not only the baseband, but also the RF, especially with millimeter wave. It's very challenging to have a complete chipset that implements all of the features of the 3GPP release. Then they have to test it. They have to do interoperability testing with the infrastructure equipment. And at the same time, the infrastructure vendors also have to build network equipment based off of the release. So both sides, the network and the device side, the activity kicks off. So the first devices that come out are usually handsets. So the latest and greatest handset that you will get will have the latest 5G speeds and features and so on. But in our world, in the IoT world, or for example, enterprise wireless, we need to build pre-certified modules so that customers like ODMs who are building routers and gateways or software-defined wide area network boxes need pre-certified modules, because they don't want to do all of the heavy lifting of chip down design. So finally, when the chipset is ready, companies like Telit will build a module around it. And basically, this is a standard module like a M.2 format, as shown here on the right. This is our FN980M, which is a millimeter wave module and fully certified for global use with 5G release 15. And I'll touch on that later. So the idea is to tell you that the whole process typically can take up to 2 years. So you may hear a lot of talk about release 16, for example, So now products based around release 16 will be coming out next year. And similarly, now that the 3GPP will freeze release 17, then the same activity will kick off with chipsets and devices and so on, and then release 18. So the real trade-off is which release, what features to commercialize that are really needed by industry to solve real problems. It's great to have the specs and the features, but at the end of the day, it's the use cases that we are solving and making life better for manufacturing, for industry, for all the verticals is really that matters. So the FN980 series by Telit is basically a 5G release 15 M.2 data card. So as you can see, it comes in two flavors. There's a sub-6 variant, the FN980, and then there's a millimeter wave variant, which is the FN980M. And this is based on the Qualcomm chipset, SDX55, and it includes dual connectivity, and it supports NSA and SA. So those are non-standalone mode and standalone mode. It has a 4G modem as well as a 5G modem and 3G fallback. Overall, it can easily reach 4 up to 5 gigabits per second downlink, and that is really the enhanced mobile broadband that Prakash was mentioning. And of course, it has integrated GNSS, dual frequency, and certified for worldwide deployment. So that's what makes it easier for our customers to take a fully certified product and then deploy it worldwide. Now, I will cover some of the use cases which are enabled by 5G by using some of these modules. So the first one is the enterprise network. So as you know, data centers and even enterprise businesses are moving towards, this trend started earlier where the primary connection was broadband or fiber, Ethernet broadband connection, but a failover was a wireless LTE connection or 4G connection. That has come a long way, and with the enhanced speeds of 5G in downlink as well as uplink, now there is basically an opportunity to replace the broadband and make 5G or wireless as the primary broadband connection for an enterprise or a small business. So basically, with that, you get reliable, robust connection, but ease of use and quick deployment. So you don't have to bring fiber and cable to a new venue. You can easily move with the business. So there's many benefits, retail shops and construction sites, manufacturing, people working remotely. Now they can buy a box which is cellular connected and gives them a broadband-like experience. And that's what the Telit module enables in routers and gateways. So again, routers and gateways are basically used in all of these applications. A picture shown here is showing you a typical ruggedized unit. This can be deployed in the field, outdoors. It can also be deployed deep into a data center inside, and it can be sub-6 or it can be millimeter wave. And basically, it's also used in vehicles, for example, mission critical, safety, first responders, emergency, especially wildfires. You can go put up a network quickly using some of these products. So that's what 5G is enabling, is all these new use cases for service, connectivity service when you need it. Another aspect of 5G is the faster uplink. So from 4G to 5G, there was a lot of work done by 3GPP to enhance the speed of the uplink. Now, uplink is very, very important because what does a camera do? A camera is all uplink heavy traffic. So once you have a connected camera with a 5G modem inside, like the FN980, you can basically have a 4K streaming or 8K streaming which was not possible before. So now with AI and machine learning and computer vision, cameras are becoming very, very popular in not only consumer applications, but also enterprise applications where defect can be automatically sensed on a manufacturing line by connected smart cameras. Or you can do broadcast from stadiums, for example, mobile cameras, which are not fixed. They could be battery powered, and drones, for example, have very high definition cameras and so on. So connected cameras is another useful use case for 5G. Private 5G networking is yet another vertical which is gaining a lot of popularity. And the verticals here are manufacturing, industrial, auto manufacturing, and also in AR and VR applications. So there is the CBRS spectrum in mid-band, which is private spectrum, which has been auctioned by the FCC. So in this scenario, you get lightly licensed spectrum where the cost of operating it really comes down, and you still get very good, reliable experience. And it's a very strong component contender to basically compete with Wi-Fi. So private 5G is cellular technology being offered similar to the ease of deployment of a Wi-Fi network. So some of these products that have the 5G capability can be used in private 5G networks. And there are many verticals that cover that. Smart grid is another one with all of the wildfires and ability to quickly shut down any downed power lines, or having connectivity of remote sites like the wind powered shown here also requires reliable 5G connectivity. So that's another vertical, very well served by 5G. Mobile computing has been around and 4G has been there, but now with the faster uplink, as I mentioned, even connected laptops can have, you can have Zoom calls, basically remote office networking, files access. Basically, you can work remotely and truly remotely with a mobile that's connected with a 5G mobile. So those are some of the use cases. Now, because of the limitation on time, I'll quickly cover some of the thoughts behind, the generations of technology and how they impact a real commercialization. So what we prepared was a chart that shows roughly a 10-year life cycle for each of the G generations, starting back from 2G and 3G, and now we're in the 4G and 5G era. So as you can see, 3G is basically going to be sunsetting in the North America the coming year, and 4G is obviously fully deployed. Now, what's important to note here is that within 4G, there is Cat-M and NB-IoT, and Prakash talked about enhancing them with the satellite front end. So all that 3GPP work is going on, but our customers care more about how long can I expect my current technology to last. And so this is where we want to show that the curves of these technology cycles are at least 10 years or more. And as 3GPP has now named release 18 as 5G Advanced, you can expect that the 5G cycle will be quite long and well into the future and with a strong roadmap. So the narrowband technologies of release 15, in fact, even back from release 13 and 14, are still 5G compatible technologies. And then the 4G lower category devices, which are Cat 1 and Cat 4. So RedCap is the natural evolution, which will eventually replace 4G Cat 1 and Cat 4. But there is still a long time before the 4G Cat 1 and Cat 4 go away, mainly because, as I said in my previous slides, the chipsets have to be built, the standard has to be finalized, and then modules have to be developed and make its way into the devices, and the price point has to come down for mass adoption. So yes, there is good future available, but our view is that the current 4G technologies are still going to be around for a very long time, but eventually will be replaced by 5G. So it's always a interesting trade-off on whether to deploy now or keep waiting, and that's where you have to see where the market is going. Also, so just covering some of the enhancements of 5G, which are basically continuously evolving. We are expanding in release 17 the millimeter wave spectrum. So obviously, we're going to go into the up to 70 gigahertz, and that brings its own challenges of propagation and beamforming and massive MIMO. So 3GPP is solving that. But more importantly, when eventually everything is native 5G NR, you can make use of the new radio. That's why it's called NR. There is a lot of inherent efficiency in the network itself, which is basically upgraded from 4G. So even the core network has many features that allow edge computing and low latency communications and robust connections, and also massive scale. So all of that is basically inherent for 5G. These are some of the early release 15 use cases that we touched on. Enhanced mobile broadband was the focus, and the early adopters definitely ran with those use cases. You can see the enterprise routers that I mentioned, connected cameras and laptops, and industry benefiting from it. But then when you move forward and you look in the future, you see, for example, agriculture, drones, AR and VR, autonomous industrial robots, for example, in manufacturing, smart cities. There's a big initiative to make the city lighting and infrastructure smart and connected. So basically release 17 and 18 onwards will definitely bring in new use cases, and the medical and telehealth is another vertical. So these are just some highlights on how the things that Prakash talked about will actually make its way into real commercial products using modules like the FN980 series from Telit. And to recap, I want to make sure we give enough time for Q&A. My last slide. Basically, 5G is going to touch almost every vertical that you can think of. They're shown here. And, for example, manufacturing is something that's really taking good advantage of, especially release 16 that is out now. It's the first time they really get a first look at ultra reliable low latency communication. And that is the beginning of the fourth industrial revolution, where the wired classical robotic manufacturing will transform into connected 5G enabled robots, which are wireless. And for example, in an assembly line, you can imagine instead of the car moving through the assembly line, the assembly takes place where the robots are mobile. They come and do their part and go away. And then the next batch comes, does its part and goes away. So it's a fundamental transformation. The tools are going to be connected. You can collect enormous amount of data from these and then analyze it using machine learning, artificial intelligence. So the future is quite bright with 5G. So hang on and enjoy the ride. That's the end of my part, and thank you very much. So let's switch back to Prakash and we'll take some Q&A now.
All right, thank you, Safi. That was very insightful, especially from the growth and how the volumes move in terms of various generations. Right, that's really insightful. So here are some of the ways. I mean, you can go to Telit, simply telit.com/5G, as Safi mentioned. For Tantra Analyst, there are many ways to connect with us. So Twitter, LinkedIn, podcast, as I mentioned. There's a newsletter that you can sign up, and its website as well. Okay, so let's go to some Q&A now. Thanks for all of your questions. I have quite a few of them. I think we can at least address some of them, or probably not all of them. So let's start with some basic housekeeping questions that many people ask. So the slides as well as the recording of this webinar will all be sent to all the registrants through email, and there is also a white paper being produced for release 17 that I'm working on. That will also be sent soon after, so don't worry about taking a lot of notes. The slides and the recording will be sent to you through email as long as you are registered, right? So with that cleared away, so the first question I have is, um, understand that this is about release 17, but is there a timeline for 6G? If there is one, let me address that first, and then Safi, feel free to jump in as well. So, I mean, industries, people always want to talk about next Gs, right? But as in many slides, me and Safi have shown, these releases take quite a lot of time. 3 years before you move from one release to other. So the 6G everybody's talking about, but nobody seems to know what 6G is. So that's the 3GPP. That's the reason 3GPP came down hard and put its foot down and said the next step from 5G that we have today is still be 5G, because 5G is in still very early stages. It's only the first step that we have, and quite a lot of things left to be done. That's the reason the next phase will not be 6G, it will be 5G advanced. So if you go back to 4G or LTE, same thing happened. You had LTE and LTE advanced, and then 5G came. Similar to that, we have 5G now. There'll be 5G advanced. I expect at least two releases, release 18 and 19. And any talk about 6G will be after that, beyond release 19. Could be release 20, 21, and so on. So 6G is still quite away, but the whole idea is to keep improving with the successive releases, and we are at a very early stage of 5G. Safi, go
So
ahead.
I will just add to that, Prakash, is like I mentioned, 2022 is the year when release 16 based modules will come out, because the chipset has already been released and the modules are being developed. So from 2022, you can imagine that the rule of thumb that I mentioned is 2 years. So you can imagine that release 17 products for IoT will be out in 2024 time frame. So I think
Correct.
that is what
Yeah.
addresses the question.
All right. Thanks. So the next question is also around the same. Can you talk about the realistic commercial timing for release 17 networks, chipset devices? When will we see RedCap, satellite, NT, and NB-IoT, and LTMA, etc. in the real world? So that's a quite a loaded question. Loaded question. We address some of it. So let me be, specifically address that. Usually, it takes anywhere from a year to 1.5 years to actually see the commercial devices after the any release is finalized, right? So release 16 was finalized in June of last year, so there already been some devices announced, not commercial, and obviously chipsets uh, for IoT. And last week Qualcomm announced this Snapdragon 8 Gen 1, smartphone platform that will support release 16 as well. So the real devices in initial volume, not huge volume, will come for release 16. I'm talking about come sometime early next year, mid next year, and so on. Release 17, the standard is will be finished by third quarter of 22. So you can expect products to be in later half, if at all, of 2023, and mainstream becoming in 2024, right? So, and then a lot of times when release is commercialized, that doesn't mean each and every feature in that release is commercialized. Well, only few of the easy features come on very quickly. RedCap is kind of a totally new category of device, so it will be a little bit later in my view, not in the early side. And also cat 1 and some of the LTM, later part of LT1, it is addressing those use cases right now. So RedCap is little bit farther than the first commercial release of release 17. So addressing NTN, we don't know yet. There's a lot of interest, but it is totally new for 3GPP. So I think it will be some time away. I don't think anybody can give you definite timelines right now for NTN. NB-IoT and LTEM, there are a few more questions on it. So let me address that right here. Um, NB-IoT and LTM are forward compatible. So, you might have already deployed LTM and NB-IoT in your network, in your 4G network. And when the network is upgraded to 5G NR, those devices still work. So in a way, LTM and NB-IoT are kind of the foundation of 5G IoT. There will be a 5G NR version of this coming in later, as I mentioned. But NB-IoT and LTM are kind of 5G IoT for now, right? So that this is this loaded question. Safi, your points.
So I would only add, because of the lack of time, a quick note on RedCap. So the initial use case for RedCap, as mentioned, is wearables. So it'll be a special kind of a category to basically have a native 5G NR device which doesn't have any 4G, reduced capability. So it's also used to be called NR Lite. So it is not going to be the mainstream Cat 1, Cat 4 replacement anytime soon. So what we are talking about in the standard is a special reduced capability 5G device, mainly for wearables. And then later, maybe in release 18, uh, down the road, is when mainstream Cat 1, Cat 4 device
Correct.
start
Yeah.
to
So
take
it's
shape.
much longer term. It will not be the first release 17 feature that will be commercialized. It's important nonetheless, but yeah, timelines are a little bit more there. Okay, so this is specifically about Telit. So Safi, you can answer this. So how does the certification process work? Does Telit have to get certified by each country individually, or do countries generally accept a centralized certification process?
Yeah, very good question. I'll just take a minute because we are running out of time. So certification is a costly process, and you need a lot of expertise to pass all of the stringent test cases. So a pre-certified module first has to go through regulatory bodies, which is basically GCF, BTCRB, FCC, RED, and many others in other countries, Japan, Korea, Taiwan, China, North America, Europe. So all of the regions have a regulatory body that regulates radio communications, so you have to go through regulatory. After regulatory, the actual mobile carriers who provide the SIM cards have additional testing requirements, which then you have to do carrier approvals. And usually those are per country. And, again, North America, there's three main operators, Europe, APAC, EMEA. So essentially, after regulatory, you do the carrier certification. Now, as a module goes into a device, if the module is the only piece that emits radio communications, then the end device certification becomes much easier because Telit has done all of the heavy lifting to do the certification of the device that transmits. What they have to do at the end device level is a reduced set of tests to make sure that the electromagnetic emissions are not harmful and the device complies with the safety standards. So this is a long process, and we help the customers along the way to get their end device certified. We do some pre-testing in our labs, we bring the product in, and then we do testing as final testing would be so that there are no surprises and they can pass on the first flow. So it's a long topic and more time to explain.
Very well. So I have one quick question that answers, and then probably one more last question. So the question was whether RedCap is network dependent or device only, or both are needed. So it's a device category. I don't think there is much. I mean, obviously, you need to support release 17 on the that kind of category on the network side, but that is minimal. But it is mostly a device feature with not so much dependency on the network. Any comment there, Safi?
Yeah.
Okay. All right. So this will be our last question. So this is What will this life cycle be similar to the other large markets like India, China, with plus or minus some years? Well, so usually, China is at the in the leading edge of new technologies. Although we looked at some of the timelines in the US and Europe, but China in 5G, China is at par in terms of timelines for commercialization for many of the releases, and I expect the same to be for release 17 and 18 as well. Very similar to the one we talked about. India is in 5G is a little bit behind. Is still now talking about allocating spectrum and some trials and so on. So, we don't know for release 16 and 17, maybe similar timelines. That is, you have the leading markets like the US, Europe, and China, and then India coming in later, maybe 1 or 2 years later than that. So, Safi, any comments from your side?
No, I think to answer it, but
Okay. So that's kind of all the time we had for questions. We still had many questions. Sorry, we could not take all of them. Many of them were regarding 6G, which you already addressed that the 6G is a little bit away. The industry is focused on, completing 5G, all the aspects of 5G first before even looking at 6G and so on, right? So it was really interesting talking about release 16, and Safi, thanks for all of information. Um,
very good
and
questions. I think we will have to contact them offline, and we'll definitely maybe do some Q&A
correct,
privately
correct,
for them.
correct, and there'll be more opportunities to ask as well in future um, uh, RCR webinars. And as I mentioned, we will also have a paper coming, a report coming that we'll send it to you as long as you're registered to this webinar, which will give you more specific and details as well. With that, again, thank you, Safi, for an engaging and informative session. And of course, thanks to all of our audience for joining and enthusiastically joining the discussion with a lot of
Yes,
questions and so
it's
on.
it's very good to see such strong participation, and very happy to see so many questions. The audience still engaged, so I'm really sorry that we didn't have enough time.
Yeah, indeed.
Longer than that.
Okay, yeah, thank you
Thank you,
again,
Prakash.
everybody, and
Thank
hope to catch you on the next one. And the reminder, the recording of this and the slides will be sent to you through email. Okay, so see you later then. Bye bye.
Bye, guys. Bye, everyone.